Hello, everyone, and thank you for joining this month's Encompass Partner Genius webinar. Before we get started, we wanted to run through a few housekeeping items with all of you. The audio for today's webinar will be streamed through your computer speakers, so make sure that your volume is turned up and that your speakers are turned on. The Nexpo platform performs best in Google Chrome or Mozilla Firefox, so make sure that you are using one of those two browsers, as Internet Explorer is not recommended. On the lower left side of your screen, you will see a question and answer box. We encourage you to ask questions throughout this presentation, and we'll be addressing them as they come in as well as at the end. If you're having trouble connecting to our webinar, refresh your web browser, make sure that you are using Chrome or Firefox, and disconnect from your VPN. If the issue persists, please clear your cache within your browser. We have how-to instructions in our handout panel if needed. All of the panels on your screen are adjustable, so you can increase or decrease the panel sizes by pulling the corners out or clicking the Maximize button located in the upper right corner of each individual panel. Today's webinar is being recorded, and it will be available on demand immediately after it has been completed. You can access the recording using the same exact link that you used to access today's live version. You will also be receiving some follow-up communication with additional information on how to access our webinar later on. Lastly, the slides and additional information pertaining to today's topic can be found in the Handouts panel located in the lower left corner of your screens. And with that, I would like to introduce today's speakers, Brian Alport and Steve Richardson.
Thank you, Danielle. Hello, everyone. Happy Halloween. The topic we're discussing today is optimizing wireless for high-performance networks. So I like starting with pictures of who's talking. I'm Brian Alport. I'm the product manager for wireless for ProSoft Technology. And with me is Steve Richardson. I'll let him introduce himself so you can hear his voice.
Hi, everyone. My name is Steve Richardson. Happy Halloween.
Okay, so with a focus on high performance or high availability wireless networks, especially those that we see in automation applications, we'll start with a quick company introduction that introduces who we are and some of our experience that we have in this market. We spent about 4 slides as the audio started. Danielle, do you think we're good?
Yep, we're good. You can continue.
Okay. So after these 4 slides, we'll move into a quick introduction into industrial wireless. This starts pretty basic for those who do not have too much experience using wireless technologies in industrial applications, but bear with us. We'll get into the deeper details when I hand it off to Steve. We'll talk in more detail about our experience in wireless applications and the key considerations when using wireless for high performance or high availability networks. So a little about us. Since ProSoft was founded, our focus has been on connecting PLCs and I/O to the rest of the automation system. Our mission has been solving automation communications problems in critical applications. It all started over 30 years ago with a portfolio of protocol converters. This is what we're best known for, enabling us to be a market leader with a lot of our technologies and to be a strong Rockwell partner, which we really enjoy. So with this expertise, we leveraged what we knew and what we learned about different complex automation systems to expand our portfolio into new technologies to help our customers better connect their equipment. About 15 years ago, we started an IEEE 802.11 industrial wireless business. This is the portfolio that we're talking about today. More recently, we developed a very nice cloud connectivity portfolio with products that allow users to securely connect to their applications from anywhere in the world. So you can see here that our focus is on connectivity and communications and really enabling IIoT for our customers. I also like to point out that we have regional offices in the US, France, and Malaysia. We have over 125 employees, and that allows us to sell into over 60 countries annually across several industries, including process manufacturing, energy generation, infrastructure, and factory automation. So since the presentation today is focused on optimizing wireless connectivity for high-performance networks, I wanted to give a very brief introduction of our wireless portfolio to give us a reference point for some of the details we're going to discuss in the next few slides. So this image shows our RLX2 wireless portfolio. These products are compliant with IEEE 802.11n for reliable wireless transmission in both the 2.4 gigahertz and 5 gigahertz bands. We offer industry-leading fast roaming times of less than 10 milliseconds, which is critical in mobile applications. We have one of the most user-friendly interfaces I've seen in this industry, which helps with fast and easy deployment of wireless networks. Our radios can be configured as an access point, or as a repeater, or as a client without requiring several different part numbers. It's all in one package. And we offer rugged IP67 and hazardous locations variants for a variety of different industrial applications. So let's look at some of our experience in the mobile automation space, which we consider some of the most complex automation networks in industry. So just in the past few years, we have worked on mobile automated solutions with over 17 multi-billion-dollar brands. These are major brands in the automotive space, as well as the food and beverage space and others. And to service these major customers, we collaborated with over 27 OEMs. These are corporations that make everything from ASRS systems to skillet systems, to electrified monorail systems, to AGVs and AGCs, and even amusement rides. And as a result of these collaborations with these major brands, we participated in over 45 multi-million-dollar automated mobile deployments, which specific to ProSoft and our wireless products translates to over 2,500 radios today. It could be over 3,000 radios installed in live applications, serving as the infrastructure for those communications. So while these are the most complex applications that we sell into, it's worth mentioning that all things considered, we have over 20,000 radios in the field today. And this is all just a little high-level background to set the stage for some of what is coming in this presentation. So one more slide about ProSoft. I wanted to highlight our market reach. This is something that I think some of you may value. So what makes us a little unique and what makes us able to best support these types of applications is our global centers of competence with wireless technologies. Our regional offices offer more than just marketing and sales, but also technical support and field application support. And this is critical, especially as we collaborate with partners on very complex automation systems. Along with our internal teams, we're also growing a network of engineering firms specifically for wireless support, commissioning, and training. This training isn't just for end users, but also OEMs and installers, so we can proactively help our customers build their wireless competence. Steve will talk a little bit about this later, but what we're trying to illustrate here is that we have our customers covered throughout the globe. Okay, on to wireless. What is industrial wireless? With a focus on the connected enterprise, I wanted to start with this simple question. Governed by 802.11, it is fundamentally the same as the Wi-Fi we all have in our homes and offices. On the industrial side, we use some different terms. For example, wireless Ethernet, wireless LAN, industrial radio, and a few others. I also think it's important to mention that wireless is a huge IIoT enabler. As more and more devices become connected to networks in our customers' applications, wireless easily becomes the favorite form of connectivity. The next slide will talk a little bit about why. So now that we know what it is, why use it in the industrial space? Wireless Ethernet is the #1 network access method in the world, especially in the commercial space. It can be used in place of an Ethernet cable. Anywhere that you run an Ethernet cable, you could use 802.11 wireless. Often wireless is preferred due to the cost of running cables, or the distance of what you're trying to connect, or the lack of accessibility in what you're trying to connect to. In some applications, it's also the only possible way to connect some types of equipment. For example, these mobile applications like cranes or AGVs. So let's look at some wireless trends. I like looking at trends when we talk about different types of technology. We just referenced the connected enterprise and IIoT, but what does that mean with reference to wireless Ethernet? Looking at manufacturing, for example, it means the potential for faster deployment of your projects because you have connectivity without running cables. It means increased uptime because you're able to pull diagnostics from your equipment that you didn't have access to before. It means smart manufacturing enabling connectivity to autonomous machines. It really is a powerful technology that when leveraged effectively can pull your applications into the present and potentially even into the future. So in the spirit of time, I won't talk about these other industries, but just know that these trends hold true across all industrial verticals. So let's jump into wireless LAN or wireless Ethernet in industrial control systems. So in the typical industrial application, we have the enterprise or the business network that pulls in data from the plant network, which pulls in data from the control network, which pulls in data from the device level network. The applications we're going to talk about are the applications where connectivity to the automation at the edge is critical. This is where industrial wireless comes into play. You have a control network that could consist of a control Logix with static switches that eventually connects back to the network core. And you need connectivity to a device or an additional automation network. It could be connectivity to a remote control cabinet, like we're showing here. It could be connectivity to an AGV with compact Logix or micro Logix or point IO. Or it could be connectivity to something like a roller coaster cart in an amusement application. They're all fundamentally the same, controlled data in automation applications. So let's look at what this means in the converged plant-wide network. The applications we're going to talk about are not at the enterprise level or at the plant information level where the network core is. What we're going to focus on is connectivity at the control level, all the way to the edge, in automation applications, in systems where there is class 1 Ethernet IP traffic, produced and consumed traffic, and fast RPIs for SIP safety. Connecting device-level networks with critical I/O. Steve's going to hit these points home. So let's jump into the applications. We can split industrial wireless applications into two general categories, stationary and mobile. The next two slides after this will show examples of schematics of each. Stationary applications are everywhere. For example, it's used in industries like oil and gas and water and wastewater for simple equipment connectivity. It's used in infrastructure for the same purpose. As we stated before, it could be used for simple control cabinet connectivity. It really is everywhere. Industrial wireless and mobile applications are quickly penetrating many different industries. At a high level in factory automation, we have AGVs, AGCs, skillets, EMS, and even cranes being deployed in factories at an increasing rate. Steve's going to talk in detail about how wireless is used to enable these different types of technologies. So let's jump into the schematics. Here we are showing a stationary application. You can see on the left side, we have a master or an access point connected to the main control panel. From this access point, we can securely connect remote equipment to the main control panel, as we're shown at the bottom of this slide. Looking at the top, we can connect to repeaters, which are able to function like a bridge connecting remote automation, while also functioning as an access point, connecting other radios, effectively enabling network extension without running cables. This is a standard and simple stationary wireless application. So this is where I hand it off to Steve to get into mobile applications and the key considerations.
All right. Thank you, Brian. So Brian mentioned stationary applications as well as mobile applications. When we talk about a mobile application, we mean an application where the automation is moving throughout a facility or is spinning throughout a single axis, like, say, a filler machine. But today when we talk about mobile applications, we're going to specifically focus on conveyance or automated material handling solutions. So the diagram that we're looking at on screen, it's showing how you have your processor and your computer, your workstation, or a server that may be connected into a control room that is also going out through the wireless bridge, the master radio, as Brian mentioned on the previous slide. That master radio is connected to other master radios on a hardwired backbone. Now, with the mobile carrier or the mobile machine, you may have VFDs, you may have HMIs, I/O, PLCs. You could have several different types of devices, even cameras that may be out and extended on that mobile carrier. It just all depends on the specific application. But the key thing when you're looking at a mobile application is that mobile carrier, it's moving throughout the factory. Now, when it's moving throughout the factory, wireless Ethernet can only go a certain distance from a specific radio to a specific antenna. So as you're moving throughout the factory, you're going to be hopping from one antenna or from one radio to another. And in this diagram, what you're seeing is that mobile carrier may have initially been connected to that master that's in the control room, but then after a certain distance along the line, it may be connected to another master. And as it continues moving, it may be connected to another master. The key thing here is the radios in an industrial wireless situation or application need to be able to roam at a fast enough rate so that the PLC can't detect that you've switched connections, or so that the HMI or the drive doesn't drop that connection while you are roaming from one master radio to another master radio. With ProSoft radios, we feature industry-leading roaming times. Those times are 10 milliseconds or less in most cases, and we do it without the need for a wireless LAN controller. So some systems that are out there require wireless LAN controllers to be able to coordinate the traffic so that you can have that handoff. We do it all within the algorithms of our master and our repeater radios. And one key thing to note here as well, those radios don't have to change and go about the factory in a specific manner. As you're seeing here on the slide where it says no set sequence of APs required, what that means is the repeater radios, they have the algorithms that determine which master radio they communicate to. So if they hear one that is a better connection, they're going to make that connection to the stronger master radio. They don't have to follow a specific path, which is one of the things that allows us to not need a wireless LAN controller or have that coordination with the system on being able to change which access point we're talking to. So now, I mentioned that we were going to talk about conveyors. We're going to talk about a few different types of conveyors that are really applicable to using industrial wireless. Now, one thing that I want to point out that's critical is, while yes, you can use industrial wireless for, let's say, a belt conveyor that is, bringing a part up to the end and you want to connect it to a trailer. But in general, when we're looking at complex applications, we're looking at applications where that mobile carrier or that conveyor has some onboard smarts, so like a PLC, a VFD, or I/O, or safeties that you want to communicate back to a stationary PLC for your control system. In this specific case, we're looking at, let's say, a skillet application. A skillet application is a mobile carrier that is basically a moving floor. So production workers can be standing on that skillet, and the skillet can make certain decisions about, I want to raise or lower or rotate to a specific angle to give you better ergonomics for the operator so that they're not bending or twisting. Industrial wireless is also good in cases where you see AGCs, for example. An AGC is an automated guided cart. An automated guided cart is used a lot in industry for delivering parts from one location to another location in the line. But also there are vehicles called automated guided vehicles that are largely different than automated guided carts from the standpoint of Either they are ride-along vehicles that people ride along on, or they're doing something more complex than just picking up a part and dropping it off at another location. So with some automated guided vehicles, they are actually even used as production lines. Now, also when you're looking at conveyance, we still also have other types. So let's say EMS, which is electrified monorail systems. These type of carriers are moving the vehicle along a single track. That track has power on it. It also has communications on it. And the EMS carrier is deciding when to move forward. It's also deciding, let's say, if it wants to lift up and down, if it wants to rotate. It all depends on a specific application. But in general, an electrified monorail system carrier needs some type of communications to be able to close the loop back to that processor. There's also automated storage retrieval systems, or ASRS systems. You see these a lot in factories where they are trying to conserve space, but they want to be able to store a lot of vehicles or store a lot of parts. You also may come across rail-guided vehicles. A rail-guided vehicle is similar to an automated guided vehicle, except it's more so fixed to a specific track. So it's kind of trapped from being able to move side to side, but it can go forward or reverse, and it's tracking to a certain speed. In this particular case, it may be tracking to a speed of an overhead carrier that you're lining up so that you can marry a body of vehicles together. You also have EMS carriers. Again, as I was mentioning, there are some EMS carriers that move vertically. There are some EMS carriers that rotate. In either case, these systems typically require the need for high-speed communications in a fashion that if those communications break, it will interrupt the functionality of the system. Some suppliers, some end users also use these type of systems as well, just to be able to get diagnostics back over wireless, where they may not have been able to do it before. But in some cases as well, they extend it out and they do their safeties, they do their diagnostics, they do their control, they tie the whole system back over wireless. It all depends on how you want to set up your specific application, but in general, industrial wireless is the medium that you would like to use for that. It gives you a lot of data, it gives you a lot of flexibility, and it gives you more access than you would have had before to a mobile system. There's also other types of rail-guided vehicles in addition to the larger kind that are used for maybe, say, body marriage. There's also kinds that are just moving along a track, and it may just have a part on it, or it may be offloading something into, let's say, a silo that it's storing a part to, or picking up a silo. It all just depends. So where does wireless come into play? When you look at this diagram, we're looking at, let's say, a conveyor system. And in this conveyor system, you may have 50, 100, 150 or more carriers on that system. Each of these carriers, as I was mentioning before, has some type of smarts that go along with them. Now, in a factory, you're typically looking at quality information, you're looking at throughput information, you're looking at part-specific information, but you're also looking at information that maintenance needs to know to be able to continue running the production line without interruptions. You're looking at preventive data to be able to understand, hey, something may or may not be working as well as you'd like it to, and you want to be able to say, hey, there's something wrong with this particular vehicle. Let's go help that operator before it actually shuts down the production line, before you get to a point where you have to stop. So when you're looking at wireless, you have, let's say, this hardwired backbone that is moving, that is connected over Ethernet back to that traffic cop or that controller, that controlling PLC. And that hardwired backbone is wirelessly connecting to every single one of these carriers. So in this case, you're looking at, there are master radios, which Brian mentioned earlier, that are connecting to the repeater radios that are in each one of these carriers. So now you have that fast connection, that fast throughput, that high amount of throughput going from that ControlLogix PLC or that GuardLogix Safety PLC down to that MicroLogix or that CompactLogix or Compact GuardLogix. You're able to do that SIP safety or the produce consume traffic or message instructions or any type of traffic in general that you're looking for in an Ethernet standpoint over that wireless connection back to that traffic hop. You can have the whole system tied together as one large 100-plus carrier system. So looking at an application in automotive, I kind of touched on it a little bit with some of the pictures that I showed you earlier. But in this particular application, it was an electrified monorail system that is lifting and lowering vehicles as well as moving them in a linear fashion along the production line. This particular customer had an EMS system installed before. However, with that EMS system, they had no communications going to each one of those carriers. So while, yes, they were able to say, hey, carriers, move forward, move reverse, lift or lower, stop or start, they weren't able to control each individual carrier, as well as they weren't able to get diagnostics from those carriers. So in a certain point of their factory, there was a blind spot where carriers typically had problems and they had no way of knowing that there was a problem on that carrier until it starved the production line later on. They almost lost an hour in every instance when this was going on. So what we did, we came in and we helped them by looking at a wireless system that is done using our wireless master radios and repeater radios, but also with radiating cable. I'll talk to you a little bit about radiating cable in the upcoming slides, but you can think of it as being a long linear antenna that is semi-flexible to be able to go along the curves, bends, vertical inclines, and declines along a conveyor. So with this particular customer, they were able to use this wireless system to connect CompactLogix that has I/O on it back to that ControlLogix. They were able to get information from the VFDs, information from the proc switches, information from other I/O that's on board, even just general status that the carrier has power. So now where they were losing an hour because a carrier may have lost power, or there may have been a mechanical issue where it couldn't drive forward, now they get early notification. They know where every single carrier is on that system. So they have that, all of that equipment connected. They have that ability to control every single carrier individually. They have that ability to look at what is going on this particular carrier. Is the current rising on that motor? Maybe we need to pull that carrier once it's unloaded and do some preventive maintenance on it so that it doesn't shut down our production line. And all of this is enabled because now you have more throughput that you can push through that medium, that wireless medium, that industrial wireless medium to that carrier or from that carrier. So now let's talk about what is radiated cable. As I said earlier, it is basically a long, flexible antenna, semi-flexible antenna. It is actually pretty rigid, but the antenna is able to be snapped in the rail, in the electrified monorail power conductor rail. It's able to be snapped above, below the rail, and it follows the entire path of the entire conveyor. Now, if you notice here in this diagram of the radiating cable, you have a few different conductors. You have some insulation. You have some dielectrics. You have an outer jacket. But the basic principle of how the radiating cable works, it propagates RF out of the slots that are cut in the cable. Now, those slots are specific to the desired frequency of that wireless network. So a 2.4 gigahertz slot will be a different size than a 5 gigahertz slot. When you're looking at industrial wireless, typically you are looking at that 2.4 or 5 gigahertz frequency range or frequency band. So where the RF is coming out of these slots, you see that there's an antenna. There's an antenna that's on board the mobile carrier that is focused at the slots that are on the cable. And it's installed at a fixed distance. So no matter what, as the carrier is going around the curves or up and down, that carrier and that mobile carrier antenna is always looking at these slots in the radiating cable, and it always has line of sight with the antenna that it is connected to. Now, some applications will not necessarily be good for radiating cable, and you will want to use a over-the-air wireless antenna because you can get better line of sight, or it's not following a specific guided track. But in a case where it is following a specific guided track, you definitely will want to look at using radiating cable because you know exactly where it's going to be, and you can control that pitch between the antenna and the radiating cable. So in practice, when you're looking at it, let's say there's a master radio that's connected to the radiating cable along the conveyor track. Now, there are several mobile clients or mobile carriers. They may have .IO, they may have compact logics, they may have micro logics. It doesn't matter what type of device in general is sitting on the mobile carrier, as long as it communicates over Ethernet. The wireless radios that are on board the carrier, the repeaters, are connected to the master radios, and as they move along the conveyor, they're talking either to that specific radiating cable segment, or when they get to a certain point and that radiating cable segment no longer has enough power to keep the connection, now it roams at a rate of 10 milliseconds or less to the next radiating cable segment. So you can see how you can build a conveyor system that may be miles long using multiple segments of radiating cable. But the key thing here is you're always keeping that line of sight to those radiating cable segments as you're moving along. Now, we're going to talk a little bit about how this affects your automation or what this does for you in your plant, having industrial wireless or having this radiating, the radiating cable segments there. So when you're looking at the connected enterprise, as Brian said earlier, or at the industrial Internet of Things, you may have a conveyor that's 700 feet in one direction or 1,500 feet or 5,000 feet in total. And along this conveyor, you have switches, you have sensors, you have stop buttons, e-stops, you have HMIs, you may have encoders, you may have VFDs. All of these different devices have to be able to connect back to that PLC for it to monitor those inputs, make some decisions, and then produce those outputs. When you look at a traditional conveyor system, even a traditional Ethernet conveyor system, you can only touch devices that you can actually get that Ethernet cable out to. So yes, you can get more data and more diagnostics from those specific devices. However, when you get to the point of, hey, there is a carrier, this carrier on board has smarts to it. It has a PLC, it has a VFD, it has I/O. Hey, can I get information from that? How can I know that my carrier is running, or how can I control my carrier? How can I propagate safeties to a specific carrier in a specific zone along the system? Can I send quality data? Can I send recipe data to these carriers? Well, yes, you can do all of these things with using industrial wireless. Industrial wireless tied into this network now makes it so that if you have that 50, 100, 130, 150 carriers on this conveyor system, those carriers are not independent little robots, if you will, that are moving around along the rail or along the floor or along the track. They are actually communicating to that control system at all times because of industrial wireless. And as we discussed before, when they get to a certain point that they hear a stronger master later on down the line, the carrier's wireless radio decides, this one sings better, this one sounds better, I have better data that I can pass through this. So it roams. and it roams in less than 10 milliseconds to that new master, and it allows it to be able to keep that connection without the control system saying, hey, something's wrong, I lost connection, I need to stop all motion. It can, even in safety applications, you can roam about from different access point to different access point at speeds fast enough that you don't open that loop and stop the carrier. So let's talk about some deployment considerations. How do I get started? You probably wonder, okay, I hear all these things about wireless, but how difficult is it for me to deploy a wireless system? In a very, very simple case, you can deploy a point-to-point wireless system very easily in about 5 or 10 minutes or less. You get the radios, you get the proper antennas, you mount them, you install them, you power them up and configure them. When you're looking at a complex system similar to the control system that you're looking at here with multiple carriers, 130 carriers, but also all the other devices that are on that system, then you may need to take into account some other considerations as well. So some of those considerations are not things that people would traditionally think of. So for that reason, we put together a pre-proposal questionnaire that we make available to our customers and to our distributors and any of the engineering firms that we partner with. We provide this pre-proposal questionnaire so that they can start the discussion, start the thought process of what does it actually take for me to deploy a successful wireless system. So some of those questions may be, what type of application? Is it a mobile application? Is it a overhead application, or is it a floor-mounted application? Does the application keep power and need connectivity the entire travel throughout the path, or does it only need communications in a certain area? What is the distance that you're trying to communicate from that carrier back to a control panel? Do you have line of sight? What type of data are you going to be sending? Is it an Ethernet IP packet? Is it a Modbus TCP packet? We need to know what type of data is going to be sent so that we can accurately model what traffic is going to be going over the medium. But also you want to know what is the data rate that you're going to be communicating at. When you're looking at a wireless application, typically we talk about packets per second. And with packets per second, so that data that is coming from that mobile carrier or from that Ethernet IP device, it's typically in a packet. And a packet has a specific amount of data in it. So you're wondering or you're wanting to know how many packets are going to be coming from this single device over the wireless medium back to that control system per second. But also, in addition to how many are coming from this carrier or this specific device on this carrier, how many devices are connected so that you can know a model of how much data is going to be moving at any point in time. If you think about it, when you're on the interstate, for example, let's say you in your car, you're one packet, and you're driving along that that interstate at a specific speed. So that's your packets per second for your car. Well, at rush hour, all these other cars come on, and they add to the number of packets per second. So now you have a traffic jam. You can't get enough traffic through. So we need to make sure that we model the interstate in this particular case so that it's large enough for all of the traffic that's going to be moving throughout that interstate or throughout that wireless medium at all times, so that the control system can always get the data that it needs when it needs it. Some other considerations that we look at as well, after we know the technical details of the application, we start thinking about, okay, what type of antennas are we going to use for this application? With those type of antennas, it may be directional, it may be omni, It may be MIMO antennas, which are multi-input, multi-output antennas. It may even be the radiating cable like we discussed earlier. It all just depends on a specific application. But by using that pre-proposal questionnaire, we can get an idea of what is going to be mechanically feasible, but also what is going to be feasible from a RF standpoint, as well as from the amount of data that you want to send or pull back through. So, for example, when I talk about what's feasible, some applications that are good for industrial wireless may be SIP safety, being able to control that carrier, that compact guard logics, from that guard logics processor that's sitting in the control room using wireless to connect the two. However, something that may not be feasible, for example, is trying to do coordinated motion over wireless. Wireless inherently has more latency and more jitter than a standard Ethernet wire does. So for that reason, we would tell you immediately, if you say that you want to do motion over that, this may not be the correct medium for you. This is not the correct application. We don't want you to go out and deploy a system and then find out, hey, there are problems. We like for our customers to call and talk to us so that we can help them understand this is what this type of application needs, and this is how to achieve that, and how to achieve it reliably without adding extra cost or extra downtime or extra integration time to that specific system. So now that we've looked at the technical details, and then we've looked at some of the theoretical coverage and placement of antennas and the feasibility of it, well, now let's get some of that equipment out there to the site so we can actually measure with the equipment. Does the theoretical line up with what we predicted? So with that, we always tell customers, if it is a complex application, if it is more than just, say, a point-to-point system or a small system that may be moving back and forth, if you have a lot of carriers on a system or a lot of end devices on a system that are going to be moving, that have to keep connections going, that have fast data rates, you want to have a site survey done. Now, with the site survey, what happens is a ProSoft engineer comes to site. They bring the equipment that they have determined with you in the theoretical coverage and placement step. They bring it to site, they power it up, they start moving around the actual path, the actual placement of where the AGV or the EMS carrier or where the radios are going to be placed or moved throughout the path. They power them up and they look to see what is the data, how is it moving, is the RF signal weak, is it obstructed, are there channels that are free? So when you talk about channels, looking at industrial Wi-Fi, I mentioned earlier, you have 2.4 and 5 gigahertz. Well, those are the mediums the RF mediums that allow the industrial Wi-Fi to be able to connect over that air gap. So let's say from where you have the control panel wired at over to where the carrier is. You want to know that you have an available channel so that you are not obstructed by something else, another system that is out there. You want to make sure that you have your own lane on that interstate instead of sharing one big lane with 100 different devices. You want only what is designed for that specific carrier or that specific system, that specific type of conveyor system to be on its own isolated channel. Some other things that are thought about as well afterwards are, okay, now I know what devices that I want to use. Now I have procured the hardware. I've received it. Great. Let me get it installed. Okay, how do I install it properly? Does it matter what orientation I place the antennas in? Does it matter what cable goes where on a specific radio? I see that the radios may have 3 antenna ports. Can I use all 3 antenna ports? Can I plug it into 2 of them? How do I decide where it goes? We provide all of this information to you when you purchase this type of system, and we design the system with you. We guide you on how to make sure that you install it properly. But not only have you installed it properly, how do I make sure that I commission it? Because I could physically screw it all in together. I could physically plug the cables in. But how do I make sure that when I commission that network, I can get the traffic that I want to be going over it, and I can integrate this wireless control system, integrate these carriers into this larger control system, and it works the way we want it to. We also advise customers on being able to take our radios, which one great feature that our radios have over some of the competition that is out there, we are able to actually talk to the PLC. So not only are we able to pass data back and forth that the PLC needs, but our radios can talk to the PLC. So now you can pull information about, hey, is that radio healthy? Is that signal good? What is the strength of the signal? Is it being obstructed? Is that antenna being connected properly to it? You can pull information from the radios back to your PLC so you can make some predictive maintenance or some predictive diagnostics based on that information. You can tie it into your upper level MES systems so that you can monitor that traffic while the system is able to run, instead of waiting for, hey, this cable was not tightened properly or tightened tight enough. It's vibrated loose and now my signal is faded. You would have been able to see, hey, my signal was getting a little bit weaker over time. Maybe I should go out there and check that carrier. So after you've actually installed the system and commissioned the system, now comes the next most critical part, which is validating the system. So when we validate a system, an engineer comes back to site, and an engineer actually does a lot of testing on the network. They check to make sure that all the repeater radios that are installed and powered are set up properly. They check to make sure that all the master radios are installed and powered are set up properly. They check to make sure that the data is flowing between them. They check to make sure that the security settings are set to the way we desired them and the customer desired them to be. They check to make sure that they can actually push and pull data through. They look at the rates and the speeds. They look at how that carrier may roam from one radio to the next. In general, validating the deployment is such a critical step in one of these large control systems. You want to make sure that it can definitely do what you expect it to do out here on the plant floor. You don't want it to be, hey, it's go time. It's time to start producing product. Hey, I can't run. You validate the deployment, we will catch all of the gotchas that are there. In general, we will catch all the gotchas that are there. Before you start production, we can help you make sure that everything is installed properly with it. So let's talk about, I mentioned some of them, but let's talk a little bit more about some general keys to success when you're looking at a high availability or high performance network. So to optimize your wireless network, some things that you want to make sure in general, no matter what, whether it's enterprise wireless or industrial wireless, but especially in industrial wireless, you want to make sure that you have line of sight between your antennas and on the repeater radio and on the master radio. Whether that is a over-the-air wireless antenna, similar to what you may have in your house, or whether that is a radiating cable antenna and the mobile antenna that's on board a carrier. You always want to make sure you have line of sight. But also, as I mentioned earlier, you want to make sure that you have an available channel that is free from other networks. You don't want to have your system that is out there running, and it's running well, and then another system is powered on, and then, hey, why is my system stopping? Why am I getting faults now? You want to make sure that you have your own dedicated channel so that traffic, all of that high availability traffic that you need at a critical moment, is always able to be able to pass the data for you. You also want to make sure that you have good signal strength when you're out there. Having an antenna that can see its opposing antenna is great, but if they can't talk to each other, if that signal strength is too low, you can't get that data over that RF transmission to go through. Like, think about it when you're in your car and you're listening to the radio. You get out of range of that antenna, and you start hearing, static or garbled communication, garbled voice. It's similar when you're looking at an industrial network. You want to make sure that you have strong signal streams, that you have line of sight, that traffic can get across that you expect it to. So make sure that you are using the proper design criteria. When you're talking to an engineer to design your network, make sure you tell them all things that you can think of about the conveyor. Even when you're looking at, hey, I want to take this cable that the antenna is connected to, and I want to move it. I want to make it longer or shorter. Those type of considerations change the signal strength that you may have from your one antenna to another. You also want to make sure you use the correct components. So as I mentioned earlier, you have a 2.4 gigahertz and you have a 5 gigahertz. There's a lot of other frequency bands that are out there in the world, but for this type of high availability network where you're doing a 2.4 gigahertz or a 5 gigahertz system, you want to make sure that you have the correct components, the correct antennas, the correct cables, the correct resistors to make sure that the network is designed properly and will operate the way that it's supposed to. As I mentioned a minute ago with cable length, you don't want to go and just put you have an antenna talking from, let's say, point A where the control system is. You don't want to go and put a cable out there that's going to go a mile and then expect that you're still going to get that same data a mile down the road when you plug in your antenna. You want to try to minimize the cable lengths between the radio and the antennas because the radio is what's pushing the power out. The antenna has to be able to receive that. The longer the cable, the less power that's there. So you want to minimize it in general. But also you want to manage traffic. You want to make sure that you talk to your engineers and that the requested packet interval, the RPI, that's the data rate of what the devices want to have that data being pulled and pushed to them from. So you want to make sure that RPI is not set too fast. A RPI of a wired network is different than an RPI for a wireless network. You also want to know the number of devices, the number of connections, especially when you're looking at a produce-consume type of architecture with a PLC type of system. You want to make sure that you are counting, hey, I have traffic that's going down to the carrier. That's going to be one connection. I have traffic that's coming back up to the carrier. That's going to be another connection. Oh, I want to have safeties. That's going to be another connection that's separate than doing standard data when you're looking at a produce-consume situation. Also, you want to try to use more and more unicast. You don't want to use multicast. You want to minimize broadcast because it just puts so much more data out there on the network than needs to be there. You want to make sure that you leave adequate capacity on your network for the traffic that needs to get through, which is why we tell you in general to use unicast messaging for those devices. Have it be a directed connection between the processor and that device. And in general, when you're looking at the system, if you are very advanced with it, if you've installed wireless systems before, if you've thought about these applications before, you can do it yourself. Great. But when you have questions, if you think that there may be something that you're not sure of, if you're doing a complex application and you want to make sure that that customer is happy when you install that, hire a pro to be able to come out and help you to look at your application and make sure that it's installed properly. So when we talk about hiring a pro, there's some professional services and support that ProSoft has available to you, whether that's access to our engineers, whether that's help with being able to properly project manage a wireless deployment that's going in. When I say properly project manage a wireless system, think about it. If you put in wireless and you're the only one in the building, hey, that's easy. But if you put in wireless and you have 30 other wireless systems that are in that building, there's some coordination that needs to be done to make sure that your system is reliable. Also, we have training courses that are out there for you. Those training courses are there for, hey, that customer that wants to, hey, I just want to learn about wireless. I don't know anything about it. I'd like to learn. But also we have different levels, the ones that are there for engineering and maintenance. I want to know about each component and how it's supposed to fit together. I want to know, hey, I make these cable lengths longer or shorter. How is that going to affect my system? I want to know about what this type of antenna is versus that type of antenna. I want to know how to troubleshoot as well as set up radios. But also we have courses that are designed for installers. Typically the engineer or the maintenance person is not the one that installs the system. It's typically an installer, an electrician that comes in and mounts the equipment, runs the cable, that they don't know anything specific about this cable versus another cable. So some of our training courses are there specifically for installers to make sure that they understand what they need to be looking at the entire time that they are installing that equipment so that they don't damage it or make you have to go back and retouch the equipment later. We also have support there to help you when you're developing specs or if you want to test specific architectures. But in general, one thing that I want to point out to all of you, our tech support, we have round-the-clock tech support that is there for you that is free. You can call in and you can talk to an engineer and run your ideas by them. You can get help when you are having some trouble with your radios. But when you need an engineer to come to site, that may be something that we charge for. We also have services that we can do to help you, whether it's system design, whether it's installation support, whether it's site surveys, whether it's drawing reviews, or let's say one big thing that a lot of our customers have, sometimes they may think of something new that they would like our radios to do that they don't currently do. One of the benefits that ProSoft has is we can develop most new features that you would like using firmware. We don't have to necessarily change the hardware. We will tell you if it's something that we can do in firmware. If it is, we'll create that firmware, that custom firmware for you. We will not charge you to create that firmware. And then, if necessary, you can have us to come to site to help you with deploying that and testing that firmware to see if it's going to work and help you to be able to phase it in properly without it interrupting your systems. We're here to support you. So with that, how can we help?
Awesome, Steve, thank you. So I went through these questions during your presentation, and there's a few that have a common theme. We've got 2 minutes left. I think we can hit these pretty quick. The first one is, can ProSoft radios communicate on the plant network, for example, with Cisco wireless devices, or can they only communicate with other ProSoft radios on their own network? This question came up a few times. I'll answer it, Steve, and then you can jump in and add your 2 cents. So yes, ProSoft radios can communicate with other devices on the network. 802.11 is the standard. Everything needs to communicate effectively. There are some devices, some 802.11 radios from manufacturers like Cisco that do some proprietary things that make that a little bit of a challenge. We can connect with Cisco. We have instructions in the download section of our product webpage that describe the different ways that we can connect with Cisco. Anything to add, Steve?
I would just add that, as Brian said, we can definitely connect to Cisco access points, and we can provide a reliable wireless Ethernet connection. But what I want to emphasize, if you have that high performance, that high availability network where you want to do your control and your safety, we recommend using ProSoft access points and ProSoft repeaters, because we know we are able to control everything on both sides of that RF medium. We can guarantee that traffic for you.
Okay, next one, I'll let you answer this before me. How do you protect against someone coming into the airspace and conflicting on the wireless channel and slowing down the communications since it's a shared medium? The question may have come in before you covered channels, but it might be good to hit it again.
Okay, great question. So first off, there are 2 aspects of that. One of them is as far as the RF medium goes, yes, it is a shared medium. There is no way to be able to force one device to not be able to talk on the shared medium, but another device to be able to talk on the shared medium, similar to how you look at the interstate. People can drive on and people can drive off at any point in time. So what we typically tell plants to do is be vigilant. Understand what you have in your plants. Understand what you are allowing your integrators to bring into your plants and connect to them. Our radios have standard industry encryption, WPA and AES encryption, for example, that is needed for you to be able to connect to that wireless network. You can also hide your SSIDs. You can also have your radio set up so that only one ProSoft radio can talk to another ProSoft radio, that it can't talk to outside devices like laptops or frequency scanners, for example. But in general, you have to make sure that you're vigilant in controlling what you allow in that airspace. We also have features that are coming in our pipeline that will be able to tell you, hey, something else is here in your airspace that is not supposed to be there. So it can help you to go track it down and to be able to report back, hey, this is what came in and this wasn't supposed to be here. We want you to be able to be successful. So we're adding features to be able to make you more vigilant as well.
Okay, great. We had a few questions specific to security. We did not cover security in this presentation, but to those points, we have WPA2 AES encryption. That's our most secure mode. We also offer a secure bridging mode, which only enables ProSoft devices to connect to the wireless network. Anything security specific you want to add, Steve?
Yes, there are other security protocols or encryption protocols that we have available as well. But in general, as Brian said, the encryption protocol that we use the most is WPA2 AES.
Okay, and the last question that I like is, I'll give this one to you, Steve. How much would a setup with a radio as a bridge, for example, increase latency? How do we want to answer the latency concern with wireless?
So what I would say is the latency of a wire, I think I mentioned it earlier in my presentation, the latency of communications over a wire is different than the latency of communications over RF. So with that, you may have typically thought of, say, 25 millisecond RPI being your standard for wired Ethernet connection. Well, that connection may end up being a 50 millisecond RPI with industrial wireless, because when you're looking at wireless, you are taking a signal, you're propagating it in the air, and you have to receive that signal, and then you have to be able to process that signal to be able to use it. So there is definitely some latency that is added to it, and that's why we strongly encourage you having site surveys done and talking to our engineers up front as well, so that they can actually measure what is that latency, what are those data rates, how quickly can that information come.
Yeah, it's a good answer. So I think in the spirit of time, that might be enough. Danielle, do you want to take over here?
Yes, absolutely. I just want to thank both of you for a very informational and engaging webinar this afternoon, and I want to thank all of the attendees for taking the time to attend and ask all of your insightful questions. For those of you who didn't get an answer to one of your questions, don't worry. We will get all of the Q&A filled out for you. It will be loaded up onto our TechConnect Genius Knowledge Base Center, and will also be linked in our follow-up communication to all of the attendees for today. So if you didn't get an answer to your question, you will get the answer, I promise you. Thank you again for attending, and thank you again to all of our speakers, and I hope you all have a great day and happy Halloween.
Thank you,
everyone.